Human visual system develops early in life. Even very young infants can master various visual functions like object or motion perception. And underlying this early maturation of the visual functions, the visual cortex, at least some aspects of it, seem to also mature really early. The structural properties like the cortical thickness become adult-like before babies become 1 year old in the visual cortex. And also it has been shown that the child visual cortex has the functional architecture that looks just like the adult brain, which means that the brain regions that selectively respond to objects or places have the same adult-like selectivity in the child visual cortex. Does that mean that the child visual cortex is fully matured and works just like the adult visual cortex? We don't know yet whether that is the case, especially thinking about the function of the visual cortex. In the adult visual cortex, we know that top-down modulation such as attention or task context can significantly impact how information is represented in the visual cortex. However, in children, the brain areas that are involved in top-down modulation, such as the prefrontal cortex, is not fully matured, and also even continue to develop until early adulthood. Thus, this makes us predict that the child brain might not be modulated by top-down factors as we typically observe in the adult visual cortex. And if that is the case, if there is weaker or no top-down modulation in the child visual cortex, the child visual cortex might represent more information than the adult visual cortex because it cannot filter unnecessary information. And we know that behaviorally that is the case. Children tend to struggle with maintaining their attention to a specific target and also often pick up the information that they are supposed to ignore. In adults, however, the visual cortex can prioritize task-relevant information, which makes us predict that the child visual cortex might represent more information than the adult visual cortex. So in this study, we are trying to understand how the child visual cortex functions with these two questions. First, we are asking whether top-down modulation impacts the representation in the child visual cortex. And also, we are asking if there is weaker or no top-down modulation, does child brain represent more information than the adult brain? We are addressing these questions focusing on these two visual features, object and motion. For object, we had cartoon pictures of 4 object categories: tree, bumblebee, car, and the chair. And for motion, it was presented using small dots moving either of the 4 directions. And to assess how object and motion information is represented in the brain, we used fMRI. And for participants, we had 24 young adults and 26 children whose age range was from 7 to 10. We had 3 task conditions which were put in each block, and within the block, each trial had an object overlapped with motion. So participants always saw both object and motion at the same time. The tasks. So first, for the motion task, participants performed the one-back task on motion, so they had to press the repeat button whenever they see the same direction of the motion twice in a row, just like the last trial in this example. And I also like to mention that they always had to press up button, so if it's not the same motion, they had to press a non-repeat button. And so in this condition, we can see how object and motion information were represented in the brain, while participants were only focusing on the motion and ignoring the object. For the object task, it was really similar, but this time they had to press a repeat button whenever they see the same object twice in a row, just like this second bumblebee. So perceptually, these two task conditions were basically the same, but participants were paying attention to different stimuli in each condition. Finally, we also had the baseline condition. Here, participants did not have to attend to either of the stimuli. It was just an audible detection task on the fixation. So again, the stimuli presentation was basically identical to other two conditions, but the fixation color was white for the most of the time, but it became pink and they had to detect this change. So this task condition provides us a neutral condition where either of object or motion was not directly attended. We are interested in these 3 brain regions, V1 and MT for motion and LOC for object selectivity. For V1 and MT, we used the probabilistic atlas from Wang et al. And for LOC, it was functionally defined, so we had a separate localizer experiment. And to assess how object and motion information are represented in the brain, we use a multivoxel pattern analysis. And we use the linear support vector machine as a classifier. Before looking at the brain data, we are going to first check how adults and children did the task. First, for the adults, I have D prime on the y-axis and task conditions on the x-axis. And we found that adults performed these tasks really well. And the average D prime was around 3, which is really high. And in children, their task performance was also really high. Again, the average D prime was not different from adults, and there was no significant differences between these two groups. And also, both groups did equally well across all the task conditions. There was no effect of the task on their D prime. Looking at the reaction time, we did observe differences in adults and children. Children's reaction time was slower than the adults, and it also differed across the task conditions, unlike adults. And it appeared that the motion task was the most challenging among the 3 task conditions. And also, as a sanity check, we wanted to make sure that the associative cortex was involved in the task that we had. So first, I'm going to show you the univariate contrast between the object task and the baseline. As shown in many other previous studies using one-back task, we do see greater activation during the task in the prefrontal regions and also in the visual cortex. And in children, we do see similar task effect. There was a greater activation during the task, even though it's a little bit weaker in children. And for the contrast between the motion task and the baseline, we see similar task effect, but a little stronger here. And both prefrontal and parietal regions were more activated during the task. And this task effect was really similar in adults and children. So as we confirmed that our task really worked, now we are going to really dive into our question and ask whether top-down modulation impacts the representation in the child visual cortex. First, I'm going to show you the decoding accuracy of objects across all the task conditions. And I want to remind you that there were 4 object categories, so chance here was 25%. I'm plotting the decoding accuracy on the y-axis and have our RIs on the x-axis. And I'm plotting decoding accuracy from different task conditions separately in each color. And we're going to first look at the adult data. First, in the baseline condition, where participants did not attend to either of the stimuli directly, we found that object categories can be decoded above chance across all the RIs. And in the motion task, where they had to ignore the object, we still see successful decoding of object across all the regions that we had. And when they had to attend to object in the object task condition, again we see successful decoding across all the RIs, but decoding accuracy was higher than the other 2 conditions in LOC. So replicating many other studies, in adults we found evidence for top-down modulation in the visual cortex. In children, first we are going to look at the data, again when object was not attended. And both in the baseline condition and the motion task condition, we see successful decoding of object information. Indeed, the decoding accuracies are not so much different from what we see in the adult data. When participants were attending to object, here again we see successful decoding of object, but the decoding accuracy is not different from the other 2 conditions. And this was even true in LOC, where we do see task effect in the adult data. So this tells us that attending to object did not sharpen object representation in the child brain, suggesting that there is no top-down modulation in the child visual cortex. For the motion, again, we are going to look at the adult data first, looking at the decoding separately for each task conditions. And we found that motion information was decoded above chance across all the regions and all the conditions. Again, there was a higher decoding of motion when participants attended to motion, which I'm plotting with the pink box. And this was again, this task effect was again RR specific. We only see this effect in MT, but not in V1 or LOC. In children, however, just like the object decoding, even though we can successfully decode motion information across all the RIs and all the task conditions, we do not see any task-related effect. Across all the task conditions, decoding accuracies were really similar. And even in MT, where we do see task effect in adults. So this answers our question about top-down modulation. We found that the task does not impact neurorepresentation in the child visual cortex. And this is really interesting given that behaviorally there was no differences in adults and children. So we are going to ask our second question, and to do so, we are going to look at exactly the same data, but slightly in different ways so that we can see how object and motion information were decoded, represented in each task condition. So first, we are going to look at the object task condition. Here, participants had to attend to object and ignored motion to do the task. So object was task relevant and motion was task irrelevant. In both adults and children, we see successful decoding of both of these motion and object information. And that was true for across all the RIs that we had. In adults in LOC, which is the brain region that has object selectivity, we see greater decoding of object, which was task relevant in this context. However, we do not see this task effect in children's data. And for the motion task, again, this time motion was task relevant and object was task irrelevant. Again, we see both type of information was decoded above chance both in adults and children. Motion information, which was task relevant, was decoded higher in MT, but not in children's data. So this answers our question. In this particular task that we chose in this study, we found that both task relevant and task irrelevant information were represented in the brain, and this was true for both adults and children. However, only adult brains seem to prioritize task relevant information. To summarize our findings, we used the classic one-back task to look at how top-down modulation impacts the child brain, and our task successfully recruited the associative cortex in both adults and children. However, this task did not impact the neurorepresentation in LOC and MT in children's data. These findings suggest that even though we know that some aspects of the visual cortex develop early in life, its function, especially how it represents information in relation to top-down signals, might be still developing in the child visual cortex. And our findings suggest that this was even true even when we don't see any differences in behaviors and the univariate contrast in the associative cortex. But why is that the case? As we see that the prefrontal cortex was activated during the task in this study, we are hypothesizing maybe it's the connection, the connectivity between the regions that are driving the differences in adults and children. So currently we are doing the functional connectivity analysis to identify the brain regions that show stronger connectivity during the task compared to the baseline. And also in this study we collected the DTI data, so we are going to look at the white matter tract to understand how the prefrontal and parietal regions are connected to visual cortex. Thank you.